I'm Tim Ventura, and we're joined today by Dr. Max Moore, a philosopher and futurist known worldwide for his work on emerging technologies and transhumanist philosophy. Dr. Moore currently serves as the Director of Communications at Biostatis Technologies, with past roles including work as the CEO of Alcor, Director of Humanity Plus, Director of Content Solutions at ManyWorlds, President of the Extropy Institute, and work as a college professor at several prestigious institutions. Dr. Moore has a PhD from the University of Southern California, a BA from Oxford, and studies at QEH with a focus on philosophy and a long-term focus on helping people stay healthy, vital, and alive past the current limit of 122 years, and helping them use technology to overcome human limits and give everyone choices about their own bodily, cognitive, and emotional functioning. So, Max, welcome. It is a true pleasure and honor to have you with us today. Again, I have wanted to interview you for over a decade at the very least, and I'm glad to be able to finally have you on. So let me start by asking what you're currently up to over at Biostatis Technologies.
Well, thanks for having me on, Tim. Natasha was pointing out your website and saying it's really fantastic. So, yeah, I'm very glad to be on here. Yeah, I've been working in the area of cryonics for quite a while. I've been interested in life extension for decades and decades, but I've been very involved in cryonics now for about 15 years, very actively, for kind of basically full time. And earlier this year, I moved from the Alcor Life Extension Foundation to work with Biostatis Technologies, which is one of a group of new organizations. And basically, its goal is to make cryonics work better, because we really want to get cryopreservation under good conditions and optimize our chances of coming back intact. So what we do at Biostatis Technologies and a couple of other organizations connected to it is to try to improve standards in the industry, try to optimize the way we do things, both in terms of the technology, the processes, how we actually go out there and do standbys and do the process, but also primarily by supporting research and doing research ourselves. And in fact, currently we're creating a new funding body that will hopefully bring in some very wealthy people to put money into funding cryopreservation research and making things work a lot better. So that's still in the early stages. But what I do primarily at Biostatis Technologies, I'm not really a researcher myself. As you can see from my title, I'm the Chief Communications Officer. So I do what I usually do, which is talk quite a lot and write a lot. The main thing I'm doing right now is to write a book on cryonics. Because people often say, well, what can you point me to explain cryonics? Well, there's a really great essay by Tim Urban. I forget what it's called right now, but it's on Tim Urban's Wait But Why website. It's probably the best essay-length introduction to cryonics. But if you ask me for a book, I'm kind of a loss. You can go back to Robert Ettinger's book from the 1960s, but that's obviously quite old. And there's no other book that I'd be happy pointing to. So I thought, well, I need to write the book then. So in the process of writing that book for Biostatis Technologies, I write a regular column for our Biostasis Substack, the Biostasis Standard. I go to conferences and give talks. I'll be going to the Dublin Life Extension Conference in August. So quite a few conferences. There's various other things we're doing, like trying to improve Wikipedia pages on life extension, which tend to be run by people who are not sympathetic, and there's a lot of distortion there. So we're trying to do something about that. So basically, a lot of writing, a lot of speaking, and joint efforts at fundraising and improving standards.
Okay. Well, so again, in terms of cryostasis, right, what we're talking about there is basically freezing the bodies of recently deceased people in the hopes of reviving them in the future. But there is also kind of a burgeoning industry here in terms of freezing tissue samples for reproductive uses. So is that something that Biostatis Technologies works with as well? Or do you have kind of a focus solely on the future revival of people?
Well, there's always something of a connection between the two, right? But other people have millions putting into general cryopreservation research. There's government funding for things like vitro fertilization, freezing embryos, various other organ preservations, getting research done by places like Harvard. So they don't really need our funding so much. We're focusing it on human cryopreservation, especially brain cryopreservation, because nobody else is going to really do that very much. Well, actually, that's not quite true. There are some academic efforts on brain preservation, but we want to focus on where it will benefit humans the most. But there is crossover, clearly, because if you're improving your cryoprotectant solutions, the solutions that prevent ice formation when you go below freezing, that benefits every kind of cryopreservation, whether it's human, whether it's cryonics or whether it's organs, whether it's brain tissue. So if we could support the improvement of a vitrification solution, then it wouldn't have to be for an organization doing cryonics necessarily, because it could still be used by those organizations. So we try to keep it pretty focused. But obviously, we keep a close eye on what's going on. There's some very exciting research just released in the last few days, where a group has finally managed to replicate what Greg Fay and Brian Wilk and others did at 21st Century Medicine, where they vitrified, which means basically freezing without freezing. In other words, taking people down to very cold temperatures without forming ice crystals. And they were able to do that with rabbit kidneys to very cold temperatures, bring them back, implant them in the rabbits, and they functioned okay. But they've had a hard time reproducing that. But now this new group has managed to do that reliably a number of times, and it's getting a lot of press right now because it's the first real major step forward in quite a while. That's really good proof of principle that you can cryopreserve not just things like what we know we can do, like skin, corneas, heart valves, skin tissue, embryos, eggs, sperm. We know we can cryopreserve those, rewarm them, and they're perfectly fine. But when you get to larger, more complex tissues, organs, it gets more difficult. So this is a proof that we can keep advancing that. So people can't really say in principle that cryonics can't work, because clearly we can do this reversibly today with all kinds of things. And as we can maybe go into later, cryonics doesn't depend on being able to reverse the process today. What it really needs to do is just get you preserved in very good conditions today, and then we can wait for the future to solve the revival problem.
That's remarkable progress. Well, so this is part of a much larger philosophy of transhumanism. So let me kind of get into that a little bit. You are one of the true pioneers of transhumanism, the author of the 1990 essay, Transhumanism Towards a Futurist Philosophy, which is actually credited as introducing the term transhumanism in its modern sense. So I guess for the audience sake, they may not be familiar with that. Can you tell me a little bit about what transhumanism is, I guess, as kind of a mantra and philosophy, and what your initial inspiration was to get into that?
Yeah, so it's kind of an interesting story around the term these days, because people who've come to transhumanism more recently have a different perspective. They've kind of read some academic papers where people have dug up stuff that did not influence me or the early transhumanists. So there are people who've even used the term before, like Julian Huxley and even Dante, but they didn't necessarily use it in the same sense. They didn't create a movement. They didn't really develop it. And I hadn't even heard of those when I started transhumanism. So clearly people have some similar ideas of some of the Russian philosophers who talked about overcoming death, which is part of transhumanism, not the whole thing. Um, but really what transhumanism is at its core is the idea that we are developing the capabilities to change human nature for the better under our own control. And that's a good thing. So it's really kind of a factual issue that we are developing these technologies. It is finally possible to start changing human nature in its fundamental biological genetic sense. And that's actually a good thing if we do it the right way. But a very core part of transhumanism for me as well is another term I coin, the idea of morphological freedom, which basically is sort of the Bill of Rights for transhumanists. It's saying that we have the right, nobody else has the right to change us against our will. If we want to modify our brains, our bodies, our motivations, anything like that, that's us, that's our body, that's our right. And nobody can interfere with that. Nobody can tell us we can't, as long as we have informed consent. And they can't force changes on us. I mean, that would be very scary if the government, very 1984, if the government could tell us what kind of people we could be. So it's a very important principle of transhumanism that's an individual choice. But that's the core idea, that aging is one of the core things here, obviously, because if we die, we can't enjoy all these other great things in the future. So number one priority really is, let's do something about death. Death is a problem. We've had to put up with it for our whole history. And so many people say, well, it's just there. We can't do anything about it. Well, that's really kind of a very foolish idea. That'd be like someone coming from a civilization where they've had slaves for as long as they can ever think of and say, oh, we have to have slavery. It's natural. There's no way we could survive without this. Well, we managed to find out that's not the case. So we've challenged all these ideas, but some fundamentals like aging and death are still stuck in people's heads, and they tend to massively rationalize these things. They try to argue that, oh, death is a good thing because it gives meaning to life, and other kinds of complete nonsense responses, because they're really rationalizing something they think you can't change. And so if I can't change it, I'd rather believe it's a good thing. Either I'm going to heaven, or else it's the end of things. I don't have to worry about the future. If you say, well, we might better fix this problem, but we can't guarantee it, people get very uncomfortable. They hate that kind of uncertainty. But that's really what we have to deal with. It's currently only a possibility. And as we can maybe discuss a little more, cryonics is a very important part of life extension to me, because I'm in my 60th year now, and I've been involved in life extension since I was a teenager. It's a long time of watching this. And how much have we extended the maximum human lifespan? Zero in that time. The French lady Calment survived to 122. Nobody has beaten her record. So there's been no increase in maximum human lifespan. All these promising animal trials have not yet translated into humans. So people are saying, oh, we're going to fix this in the next 10 or 20 years. I'm saying, well, be a little bit more skeptical. Think about other alternatives, because the odds are we're not. Unless, and this is the big wild card, artificial intelligence might change the game. It's not ready to do that right now, and I'm kind of worried that a lot of people are going to stop AI progress, or going to do their best to overregulate it. So I've been fighting against that a lot recently. But without AI as boosting progress, it could take, we don't know how long, another 50 years, I'll be dead. So that's not very helpful, and billions of us will have died in the time. So if that's a likely possibility, or any kind of probability, cryonics is kind of a very important backup step. It's really actually the first thing you do is to get your cryonics arrangements in place, because you could die at any time. You could walk outside and get hit by a car. You could have an aneurysm, you get shot. All kinds of things could happen. So I like to sort of compare it to financial planning, where you have a portfolio of investments. And what's the very first thing you should do? Well, an emergency fund, right? That's the thing they tell you. First of all, have 3 months or 6 months of cash that you can survive on before you go into more speculative investments, maybe higher return. I like to think of cryonics as the emergency fund for life extension. So get that in place first, because you may need it any time, but even if you don't die of something early, we are not guaranteed that life extension will take off in time for us. So it's really a very core part of the life extension portfolio, if you like.
Yeah. Well, one of the things that has intrigued me, I have followed your work as well as transhumanism and Natasha's as well since the 1990s. And it seems like over the last decade, there has been this explosion of interest. This community is growing. It is gaining momentum and gaining mass. And so I guess part of that, I was wondering if it's a result of the aging boomer population that may be just pushing this forward. And then I think another part of this that I've wondered about is transhumanism has traditionally involved ideas like body augmentation, right? As you mentioned earlier. And now we are seeing artificial joints, implants, and other technologies regularly implanted in humans. So do you think that these are inspiring people to view this as something that's possible and practical and real, right? And are we seeing kind of a spectrum of transhumanism emerging, I guess?
Yeah, Rose, I didn't actually answer all of your previous questions, so maybe I'll come back to that. You asked me how it got started, so remind me to come back to that. But yeah, to address what you're asking now, yeah, transhumanism has really grown, and sort of in part from the previous question. The way I looked at it from the basically late 80s, early 90s, in the early days of modern transhumanism, it was considered to be a wacky idea by pretty much everybody. They thought it was very science fictional. But today, it's very interesting. We can look back at issues of Extropy magazine that we published back in those days, the late 80s, early 90s, and we're seeing all these things about digital currencies, which nobody talked about until decades later, about life extension, neural networks. I mean, there's on and on, space colonies. There are many things in there which today people are going, oh my God, you guys talked about that back in the 90s? So yeah, we were kind of ahead of our time. Now, or back then, so if we discuss these ideas, the usual response was, that's just crazy, that's not going to happen. Today, the response is more likely to be, oh my God, yes, we're going to have AI, we're going to have genetic engineering, we're going to have new body parts. We should do something about that. We should stop it, or we should shape how it happens. So the conversation has really changed. The idea has spread very widely, and it's gone from this can happen versus this can't happen to, yeah, this is going to happen, but how should we respond to that? Should we try to control it in some way? Or slow it down. So that's kind of the major change in the conversation. And as you mentioned, I think the fact that we're seeing people with very cool designs of new legs and when they've lost their limbs, we're seeing cochlear implants to help people hear again, deep brain implants to help people with Parkinson's disease and other conditions, and of course, all the recent developments with artificial reality and virtual reality and combinations of those, which had a brief boom in the 90s and didn't quite work out. But of course, we've developed the technology much further. So all of these things are now actually out there in some form or another, except maybe working life extension, as I would argue. So it's made transhumanism a lot more plausible, and people look around for a philosophy that makes sense today, and they realize, well, there is one there which actually addresses these issues and has thought about them quite deeply.
Yeah. Yeah. Well, one of the things I guess that I'm hoping to see is more of a shift in perspective on human aging. As you mentioned earlier, I think that we still consider aging and death to be inevitable. And it seems like there is at least the beginnings of a shift towards maybe a disease model, I guess, with life extension research as kind of a search for the cure, similar to cancer research. Do you see that taking root? Is that moving forward? And how much progress is needed, I guess, to start to shift that psychological factor where people view these things differently?
Yeah, it's interesting that just really in the last few years, we've been arguing for decades that we should see aging as a disease, basically. I mean, it's pretty clearly a disease or a set of diseases, if you like. Many people have argued against that, and they'll point out that the FDA doesn't consider aging a disease. You cannot submit a drug as an anti-aging drug. It doesn't recognize that as a thing to solve. Just very recently, that there's hints that might be starting to change. It hasn't changed fully, but the recent trial on metformin, the TAME trial, as it's called, uh, forward at least two different things that it could do, both kind of basically explicitly tied to aging. And the FDA has accepted that trial as a formal trial. So that's kind of the beginnings of a crack in the FDA's very kind of traditional bureaucratic approach that has its categories and you can't apply to do anti-aging therapy. That's very important because obviously it's going to be hard to raise funds for doing clinical trials for something the FDA is not going to recognize. Unfortunately, in the system we have in this country and many other countries in some form, the cost of developing new treatments can be massively expensive because of huge overregulation by the FDA. It's a whole topic in itself, but I think it's actually killed tremendous numbers of people because the FDA essentially is not motivated to have the best effects on people. It's motivated by people running it to avoid danger to themselves. Because if you
Yeah.
approve a drug like thalidomide, which has horrible effects, they're going to point to you. You're going to be vilified in the media. You could be fired. All kinds of bad things will happen. So you're going to tend to be overcautious because you get none of the benefits of the good things happening. And people don't see all the people that die by the lack of a treatment because that's just kind of distributed in the background. You don't see that. So these regulatory agencies tend to be very overly conservative and very risk averse. So we need to do something about that. I think people are finally recognizing that because of two things, actually. AIDS, where the AIDS activists managed to get the FDA to loosen some of its rules for AIDS treatments, and that helped to speed those up. And of course, COVID, where we had an emergency use authorization for the vaccine. And so now people are asking, well, why don't we have that for other drugs that could be helping huge numbers of people? It takes $1 billion or $2 billion to bring a new drug to trial, to the market, and it can take 10 years or more. That's incredibly expensive and long. Why don't we accept, for instance, the results of the European agency that's equivalent to the FDA? If they find it to be fine, why do we need to do the whole thing over again here? It's really insane. So there's many possible revisions we could make that will help with the aging issue. But there's also a mindset that is still very common, but we're starting to beat it down now, is that, yeah, aging is not a disease. It's not something we should try to fix. We should just make people healthier, have healthier old people. Let's kind of square the curve where you don't decline. You kind of stay healthy and then you just drop off suddenly at the end. Well, that's good, but it's not enough. The idea that we should die at a certain age just makes no real sense because there's no divine command that thou shalt die at 122 or 119 or 100 or whatever number. There isn't a particular number. Even if you're religious, if you're a Christian, for instance, you go back to the Old Testament, you find people living for 700, 800, 900 years. So maybe we just need to get back to the normal if you have a religious view. But from a kind of a naturalist point of view, the reason we age basically is because it wasn't worth evolution's effort. And I'm obviously anthropomorphizing here. It's not worth it to evolution to build a creature that can last indefinitely, because all evolution cares about is to pass on the genes to the next generation. You're basically just a vehicle for your genes. So long as you live long enough to reproduce, it doesn't care what happens to you after that. That's why we start declining after the reproductive age. But that's not our purpose. We have different purposes than nature. There's nothing wrong with us trying to live longer. And obviously, we've extended average lifespan quite a lot in the last century. So it's really an opportunity for us to see the good things about life that we tend to forget as we get old too. And this is kind of a scary thing that people who are enthusiastic about life extension or cryonics, as they get into the 70s and 80s, start to get diseases, maybe Alzheimer's disease, chronic pain, they start to forget why they wanted to live. So it is important that we actually make people healthy in their old age. So they remember what's good about life. And if life is good, if doing things good, is being creative and producing things is good, having relationships is good, why is more of that not a good thing? So I think really, also I should mention the status quo bias here. One argument I have why people who say the right age to die is what the age is today. Well, obviously you can say in the past that wasn't the case because we died a lot younger. Why is the right age exactly today's age? If it was 40 in the past average, and you think, well, that was too short, why is today just coincidentally exactly the right age to die? It doesn't really make any sense. So if they need to have some really good justification for that, and they really don't. They make up all these arguments. I recently published a blog piece that's on my Substack blog, looking at all the really bad arguments, the common arguments, and how to answer them. And one of them is that if we live indefinitely, we'll get bored, or life will lack meaning, which I think is just complete rubbish. It's really foolish when you look at it. I think actually having more life will give more meaning to life, because your actions today will have repercussions, into the future, which you're going to deal with. So, whereas if I was going to die tomorrow, things I do today seem somehow less point to them. So I think it's actually the opposite. And you're not going to get bored, because right now I could take out my notepad and I could write down things to keep me busy, things I want to learn, things I want to do, things I want to experience, will keep me busy for tens of thousands of years. And by the time those years have gone by, there's going to be a whole bunch of new stuff to do and to learn. So I think people who say that they'll get bored are just boring people. They're already bored with their life now. And you can see teenagers who are, oh, I'm so bored. How can you be bored? Well, it's an attitude. So if you're the kind of person who likes to explore and grow and build things and create things, I don't know why you wouldn't want to have the health to do more of that. And keeping in mind, we're not talking about extending the years of miserable life. We want to extend healthy lives. We want to bring back people from cryonics at a time when we've conquered aging. You'll come back in a new, vibrant body at your peak. Any issues you had should be solvable too. If you had attention deficit disorder or depression or anxiety, those should be fixable if we have that kind of technology. So we're talking about a you who is the best you ever, and probably getting better and better as we integrate with technology and manage to improve our brains in various ways. We can talk about some of those issues to fundamentally overcome human limits. There's a lot of possibilities ahead of us in the future, and I think it looks pretty exciting. Obviously, there are dangers as well. This is not a utopian viewpoint. Big risk right now, of course, is AI being discussed, but there's all kinds of, it used to be nanotechnology and other issues. There will be things to deal with, but the basic idea is if you enjoy living now, why wouldn't you want to continue living into the future?
Well, I think this is more timely than ever also. Total fertility rates have fallen below replacement levels in over 25 nations, including the United States, Russia, China, and much of Europe. One consequence of this is an overall aging of the population, right? And I think that when we combine that with the large baby boomer population, which is also aging, it seems like that makes the need for life extension more important than ever. Would you agree with that?
That's exactly right. Yeah, I've actually written a piece on this where I have a look at the overpopulation argument. You can also find that on my Substack blog, which is just maxmore.substack.com. Just recently put something up on that where I've been writing about population actually for decades. It's something I've been interested in for actually since my teens, so I've been following it for a long time. And what's interesting is people still talking about overpopulation and why there are too many people and how life extension would be bad for that. And it's like they're living 50 years ago. Fertility rates peaked in 1968 or 69, something around there, and they've been falling ever since everywhere. And yet we have the same argument coming up. Whereas, as you say, in increasing parts of the world, pretty much all the Western world, pretty much with few exceptions, we don't have replacement rate population growth. So basically, if we're not replacing people, unless we get a lot of immigration, population is going to fall. And the scary thing about that is it can actually fall to zero if you never change that. So what we're already seeing in all of Eastern Europe, we're seeing in China, and to a less extent in some of the Western democracies, and a little bit less so in the US, but still the case, is an aging population. China has it really bad because they forcibly reduced fertility for a long time. They had the one-child policy, the centralized policy, which was a huge disaster, like these kind of coercive policies usually are. And now they're finding that because they suppressed that, people are now so used to it, they're trying to give incentives, financial incentives. It's not working. Their population is going to age very rapidly. So their population will slowly shrink, but the working age population is going to shrink faster. And that's one reason I'm not so fearful of China as the big rival. I think actually India is going to be a lot more influential in the future. So yes, we need to do something to stop population plummeting in the near future. You can look at the global numbers, but that's kind of misleading for us because we're much further along on the process. But even in Africa, what you've seen is, although we see it as a high fertility rate still, it's much lower than it was in the 60s or the 70s. It's going down pretty much everywhere. And as you get more education, women have more opportunities. It seems that happens everywhere. It's an inevitability. But the Western world is already far past that point. We're already in this declining stage. The US a little bit different because we have some higher fertility subpopulations. We, at least until recently, had a fair amount of immigration. But obviously, you can't solve the world's problem by immigration unless we get aliens coming in from another planet.
So not all of the elderly will live long enough to benefit from life extension treatments, and that's what brings us to cryopreservation. So, again, you were the president of Alcor for many years, and as you've mentioned before, the idea is freezing deceased humans in the hopes of providing them with future advances in technology. You'd mentioned that this technology is moving forward and continuing to move forward. Do you feel good about where things are going right now?
Yeah, so I've been actually involved in cryonics for a very long time. I started the first cryonics organization in Europe back in 1986. I moved over to the States the next year, so other people took over. But I've been a member of the Alcohol Life Extension Foundation since 1986, so a long time. I actually signed up when I was 22, when I wasn't really expecting to need it, but I did that as kind of a statement that this is a sensible thing to do, because I do believe in living by principles. You can't just talk about these transhumanist ideas; you need to put them into practice. So over that time, there's been definitely a lot of progress. The core idea, as you say, is many people today are not going to make it to a time when we have real life extension. It's interesting. A lot of some quite well-known people seem to coincidentally think that the singularity or the anti-aging revolution will happen just in time for them, which is a bit coincidental, I think. Again, I'm lacking in a lot of that confidence right now. I don't know when it's going to happen. I don't. We have a bad record of predicting things, so I wouldn't rely on that. So cryonics is very important. Put that in place first. And yes, the core idea is we want to take you at the point of legal death because we can't do it before legal death for legal reasons. If we stop your heart, then it would be homicide technically, even though that's not the idea. So we have to wait till legal death is declared. Then ideally, we're right there at the bedside. We immediately begin external cooling. We inject you with various medications to protect the cells against acidosis and lack of oxygen, antibacterial, all kinds of solutions that we've researched over the years and keep improving. And then we're going to use essentially a mechanical CPR device to pump on your chest to take over the heart function, a respirator to take over your breathing. We want to restore circulation, hopefully within minutes of legal death being declared. So very important point is that people think of death as this is it, you're dead suddenly. You're alive, then you're suddenly dead. That's completely false. And I'm actually writing a lot about this in my current chapter of the book. But historically, all these cases of people thought to be dead who then came back. The point of where we call people dead has changed over time. It used to be, before the 60s, clinical death, which really just means cessation of respiration and breathing, respiration and stopping of the heart. That used to be considered death because we had no way of reversing it. Today, if your heart stops beating, you stop breathing, we don't say you're dead. We say, oh my goodness, this person's clinically dead. We need to restart their heart. We need to do defibrillation or CPR. And so we don't consider that dead anymore. So it could be that we're making a mistake when we call someone dead today, just because the doctor doesn't know what else to do to bring you back. In fact, in many cases, they'll declare you dead because you have a do not revive, or they just think it's pointless to try to revive you, but they could revive you. So again, it's not really a clear line. So we're trying to get in there quick enough that you're not really dead in the sense that matters, which basically means your brain and your memories and your personality, which are encoded in the physical structure of your brain. That doesn't go away in 2 minutes or 5 minutes or even an hour. But the sooner we can cool you down, which slows down metabolism, slows down the decay process, we should then be able to preserve you under pretty good conditions, use a vitrification solution to prevent ice formation in the blood, basically remove as much blood as possible and replace it with a different solution that just gets thicker and thicker, kind of like glass, and holds everything in place without any ice crystals. Now, not every case gets a complete treatment like that. It's not always possible. Someone's not found for a long time, or they have some problem in the brain. So there's no guarantee that we can cryopreserve somebody under perfect conditions every time. But hopefully we do a pretty good job most of the time. And we think we have pretty good evidence that under decent conditions, we do preserve the essential structures in the brain that encode memories. Now, we don't have a full understanding of memory yet, but we do know that it's not electrochemical, except for short-term memories, the last 20 minutes or so. If you're knocked unconscious, you typically won't remember the last 20 minutes. If you have anesthesia, deep anesthesia, you'll lose those memories because they haven't been fixed physically in the brain yet. But any long-term memory is there in a physical structure. We have some understanding of how that works with connections between the brains, changes in synaptic weightings. And we have good evidence now that we are preserving those structures under good conditions in cryonics. So we're pretty sure that under good conditions, we are preserving those structures. You are still there. We cannot reverse that today, but that's no kind of objection to cryonics, because the whole point of it is technology will continue to advance, as we keep seeing in these new studies showing that. So once you're at that temperature, basically minus 320 Fahrenheit, you're not going anywhere. Nothing is going anywhere. You're completely stopped metabolically. You're basically a coma patient, but with no metabolism. If you wait 50, 75, 100, however long it takes, we should be able to develop a technology that can go in there, repair the cells, reverse the aging process, because we don't want to bring you back as an 85-year-old, or that'd be kind of pointless. Now, there may be cases, actually, I think one question you were going to ask, there may be cases where you could be brought back sooner. For instance, if you died at the age of 25 from cancer that becomes easily curable, if we'd actually improved the process enough that we could bring back people with minimal damage like that, then I guess in principle you could do that, because they'd have a lot of time ahead of them if they thought aging was another couple of decades ahead. But the general assumption is we'll wait until we've cured the aging problem, and we wake you up and you go, what year is it? We'll tell you 2098 or whatever, and you'll take a look in the mirror and go, wow, I look damn good. you wouldn't have looked that good for a long time. So there'll be some future shock, presumably, but you also have the benefit that you're now feeling really good again, and I think there'll be people there to help you who are trained to do that.
But do you have any idea what the timeline is to revive the first patient from cryopreservation? Or, as you mentioned, is this entirely dependent on being able to solve, I mean, the chronic illnesses that led to their passing in the first place?
Yeah, I think there's no way we're going to revive someone until we have technological capabilities that can fix a lot of the problems we have today. It's just going to require, well, arguably for some people cryopreserved later under really good conditions, there might be fairly minimal damage that it might not take too much advance to bring people back, since we can already do it with organs. But in most cases, there's a lot of damage done by the time you die, certainly of old age. Um, and then there's going to be some damage after that point. It's going to take something like a medical nanotechnology or something equivalent to get into the cells and do the repair. If we have that kind of capability, we'll better destroy all the viruses, we'll better fix Alzheimer's disease, we'll better fix pretty much anything. Maybe there'll be new diseases arising, but then we'll also have much better capabilities to reverse those and find cures. So we're really talking about bringing people back when we've solved all those problems.
Ah, well, Max, let me thank you so much for your time today. It's truly been an honor to have you with us. So let me close by asking, what comes next for you, for transhumanism, and for Biostasis Technologies? Where will we be seeing you next in the headlines?
Well, I'm actually working on two book projects. So one thing is that although I've been involved in transhumanism, basically helped to start transhumanism in the modern age, I haven't really put out a book other than the Transhumanist Reader that I edited together with Natasha, which is a good source for people. But I'm actually putting together a large volume collection of my essays over the last 30 some years. And I'll be self-publishing that. That should be out fairly soon. I'm also working on, as I said, on the Cryonics book. That's going to take a little bit longer, hopefully out sometime next year. If people are interested in these ideas, I suggest they subscribe to my Substack blog. It's free to subscribe at maxmore.substack.com. I'm writing a lot about AI risk right now, as well as anti-aging and a lot of related issues to do with technology and technology regulation. As for the Biostasis Technologies, again, one of the main things we're doing is trying to create a new fund to allow wealthy people, who anybody who's got some money, to really make a difference in cryopreservation, especially because it doesn't get enough funding. We could probably do a lot more if we had more funding. So hopefully we'll see not just the advance we've seen in the last week, but we'll see more of these coming up, and people will become more convinced that cryonics is a sensible thing, and maybe I should do something about that.
Max, thank you again so much for your time today,
Thank
sir.
you very much for having me on. It's been a pleasure.